Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we are focusing on how to implement and maintain changes effectively within a secure change management framework. This includes three key areas: testing and test results, backout plans, and the use of maintenance windows. These components help ensure that changes are applied smoothly, safely, and with minimal disruption to operations. Let's begin with test results. Testing is one of the most critical steps before any change is implemented. Whether the change is a system upgrade, a configuration tweak, or a software deployment, testing helps confirm that it works as expected and does not introduce unintended problems. Testing is your chance to catch issues before they impact real users or systems. The importance of testing cannot be overstated. Without it, organizations are essentially gambling with stability and security. A patch may fix one vulnerability, but create new compatibility problems. A new configuration might work on one server, but fail on another. Testing in a controlled, non-production environment allows teams to observe how a change behaves, identify unexpected outcomes, and fine-tune the implementation. Once testing is complete, interpreting the results correctly is essential. It's not just about whether the change technically works. It's about whether it works in the way it needs to, under the conditions in which it will be used. For example, a new feature might function perfectly in a lab environment, but cause performance issues when deployed at scale. Security teams must look at logs, performance metrics, and feedback from testers to determine whether the change is ready for production. Real-world examples show what happens when testing is skipped or done poorly. In one case, a retail company rolled out a point-of-sale system update without testing it on all device models. Some stores experienced crashes and could not process payments, leading to lost revenue and customer frustration. In contrast, another organization tested a similar update in a simulated environment that mirrored every store configuration. When they deployed, the process went smoothly and no downtime occurred. The difference came down to testing discipline. Now let's talk about backout plans. A backout plan, also called a rollback plan, is a documented procedure for reversing a change if something goes wrong. It's the safety net that allows teams to recover quickly if a change causes unexpected problems. Without a backout plan, even a minor failure can spiral into a major outage. Developing a strong backout plan involves more than just saying we'll uninstall the update. A complete plan includes step-by-step instructions for undoing the change, a list of people responsible for each action, communication steps to inform stakeholders, and verification that systems are back to their original state. It also includes a clear time frame. If the change isn't fully successful within a certain period, the backout begins. Deciding when to trigger a backout plan requires criteria. This might include a specific error threshold, system instability, user impact, or failure to pass post-deployment checks. Teams should agree in advance what conditions will lead to a rollback so that decisions are quick and clear when time is critical. Case examples help bring this to life. In one situation, a financial firm upgraded a database system over the weekend. On Monday morning, users reported slow performance and incorrect data results. Because the team had a well-rehearsed backout plan, they were able to restore the previous version of the database in under an hour and resume normal operations. In another case, a company applied a firmware update to hundreds of devices but had no rollback plan. When the update failed, they had to reconfigure devices manually, resulting in days of downtime. Planning for failure can be the difference between a quick recovery and a disaster. Finally, let's look at maintenance windows. A maintenance window is a predefined period of time set aside for making changes to systems. These windows are scheduled during low usage periods, often overnight or on weekends, to minimize the impact on users. They serve as an organized way to manage when changes occur, communicate with stakeholders, and ensure that support teams are available if problems arise. Defined maintenance windows are critical for operational stability. If changes happen without warning or during peak hours, they can disrupt business processes and frustrate users. Scheduling changes during known windows sets expectations and provides structure for both technical teams and users. Coordinating changes within maintenance windows also allows for proper staffing. System administrators, help desk teams, and managers can be on standby in case a change needs to be adjusted or rolled back. This coordination increases confidence in the change process and improves the organization's ability to respond quickly if needed. Best practices for maintenance windows include documenting the schedule in advance, informing users through multiple channels, and requiring that all changes be approved and tested beforehand. It's also smart to include a buffer at the end of the window to verify that systems are operating normally before returning to full production. Sticking to these practices helps avoid last-minute surprises and builds trust in the change process. For the Security Plus exam, expect to encounter questions about each of these concepts. You may be asked to explain the importance of test results or identify the correct time to initiate a backout plan. You might see a scenario where a change fails, and your job will be to choose the missing step. Often, it will be poor testing, no rollback plan, or failure to use a maintenance window. Focus on understanding how these steps work together to reduce risk and improve reliability. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.